Right now, tell me how you know the Earth is round. Really think about it. Most people can't answer that without saying satellites or NASA, but here's the part that should bother you. Humans calculated the exact size of this planet within 2% accuracy, over 2,000 years before rockets existed, using a stick, a shadow, and nothing else. So how did they actually do it? You've never seen the curve of the Earth with your own eyes. You've never floated in space. You believe it because you were told and because photos exist. But someone thousands of years before cameras, before airplanes, before anyone had left the ground, looked at the world around them and figured out its actual shape. No satellites. No math you'd recognize from a textbook. Just observation, patience, and a stick in the sand. Let's go back to where this actually starts, and it's earlier than you'd think. Around 500 BC, Greek philosophers were already arguing that the Earth was round not because of any direct evidence, but because a sphere seemed like the most perfect shape, and they figured the universe should be built on perfection. That's not science. That's philosophy dressed up as science. The real evidence came later, and it came from something much stranger: ships. Sailors in the ancient Mediterranean noticed something that never quite made sense. When a ship sailed away toward the horizon, it didn't just shrink and disappear evenly. The hull vanished first. The mast stayed visible a while longer, sticking up out of nothing like the ship was sinking into the sea itself. On a flat surface, that shouldn't happen. Distance should just make things smaller, not make them disappear from the bottom up. But on a curved surface, that's exactly what you'd expect. The horizon itself was cutting the ship off, bottom first because the sea curved away underneath it. Any sailor who paid attention long enough eventually noticed the same thing in every direction, every time. That kind of consistency is hard to explain away. There was another clue too, one that had nothing to do with ships at all. Travelers moving north or south noticed that familiar constellations shifted position in the sky, some rising higher, others dropping toward the horizon, and eventually disappearing altogether. A star that hung directly overhead in one city might sit low near the horizon 1,000 miles away. On a flat plane, the entire sky should look identical everywhere. The fact that it didn't, that the sky itself seemed to tilt as you traveled, only made sense if the ground beneath your feet was curving away in the same direction. Aristotle noticed something else. And this one is even harder to argue with. During a lunar eclipse, when the Earth passes directly between the Sun and the Moon, the Earth casts a shadow onto the Moon's surface. Aristotle pointed out that this shadow was always curved, always circular, no matter which direction the eclipse happened or where you were standing on Earth to watch it. Only one shape casts a perfectly round shadow from every single angle: a sphere. A flat disk would cast a straight line or an oval sometimes, depending on the angle. It never did. It was always a circle. So by around 350 BC, you had philosophers agreeing the Earth was round based on shadows, ships, and stars. But agreeing it was round is very different from knowing how big it was. And that's where the story gets genuinely wild. Around 240 BC, a scholar named Eratosthenes was working at the Library of Alexandria in Egypt, running the largest collection of knowledge in the ancient world. He heard a strange detail buried in a travel report. In a city called Syene, far to the south, there was a deep well where, once a year, at noon on the summer solstice, sunlight hit the bottom of that well directly. No shadow at all, straight down the entire shaft. Eratosthenes knew that in Alexandria, on that exact same day, at that exact same time, a vertical stick still cast a shadow. That difference was the entire key. If the sun's rays are essentially parallel because the sun is so far away, and one location gets a shadow while another doesn't, the only explanation is that the surface between them is curved. So he measured the angle of that shadow in Alexandria. It came out to about 7.2 degrees, roughly 1/50th of a full circle. Then he paid someone to pace out the distance between Alexandria and Syene on foot, step by step, counting every stride across the desert for hundreds of miles. If 7.2 degrees of curve equaled that distance, then the full 360-degree circumference of the Earth had to equal that distance multiplied by 50. His final number came out to roughly 25,000 miles. The actual circumference of the Earth is about 24,901 miles. He was off by less than 2%, using a stick, a well, a shadow, and someone else's footsteps. No telescope, no satellite, no modern equation, just geometry and the willingness to actually go measure something instead of guessing. And he wasn't the last person to check the math. About a century later, a Greek astronomer named Posidonius ran a completely different version of the same experiment, using a bright star instead of the sun, measuring its angle from two different cities at the same moment. He landed on a slightly different number, but still in the same ballpark. Still a real sphere with a real measurable size. Two independent methods, 100 years apart, using completely different reference points in the sky, kept agreeing with each other. Here's the part that should genuinely bother you a little. This knowledge didn't disappear afterward, it spread. Educated people across the ancient world knew the Earth was round and roughly how big it was for the next several centuries. Roman scholars taught it in their schools. Ptolemy wrote it into his astronomical textbooks, which stayed in use for over 1,000 years across multiple civilizations. Islamic astronomers picked up the same tradition and pushed it further. In the 9th century, a group of scholars working under the Caliph al-Ma'mun in Baghdad took a team out into the open desert, split into two groups walking in opposite directions from the same starting point, and measured a single degree of the Earth's surface directly using rods and ropes stretched across the sand. Their result landed remarkably close to Eratosthenes' number, off by a margin so small it still impresses historians of science today. None of this stayed locked away in libraries either. Sailors and navigators actually used these numbers. Medieval maps carried estimates of the Earth's circumference baked into their calculations, and the entire practice of long-distance navigation, judging how far a ship had traveled by the angle of the stars, only worked because everyone doing the math already accepted the planet was a sphere of a specific, calculable size. The final, undeniable proof came in 1522, when a fleet that had set out under Ferdinand Magellan, though Magellan himself died partway through the voyage, became the first expedition to sail all the way around the planet and return to where it started. You cannot circle a flat surface and end up back at your starting point facing the same direction. That single voyage settled, physically and permanently, what mathematicians had already worked out on paper 18 centuries earlier. So where did the everyone thought the Earth was flat myth actually come from? Mostly from the 19th century, weirdly enough. Writers like Washington Irving, the same guy who wrote about a headless horseman, wrote fictionalized stories about Christopher Columbus that invented a dramatic scene where Columbus had to convince a room full of flat Earth-believing scholars that the world was round. That scene never happened. Columbus's actual argument with scholars wasn't about the shape of the Earth. Everyone in that room already agreed it was round. His argument was about the size. Columbus thought the Earth was smaller than it actually is, using a number far off from Eratosthenes', which is part of why he thought he'd reached Asia, when he'd actually just bumped into the Caribbean. The myth stuck because it made for a better story. A lone genius defying ignorant authorities. The truth is less dramatic and somehow more impressive. Nobody had to be convinced. The shape of the Earth had been settled science for over 1,700 years before Columbus ever got in a boat, passed down through Greek libraries, Roman classrooms, and Islamic observatories, all agreeing on the same basic fact using completely different tools, in completely different centuries, on completely different continents. So here's the full picture. Around 500 BC, philosophers guessed the Earth was round because they liked the shape. Ships vanishing hull first, shifting constellations, and curved lunar shadows turned that guess into evidence. By 240 BC, one man with a stick and someone else's footsteps calculated the size of the entire planet and landed within 2% of the real number. A century later, someone checked his work with an entirely different method and got the same answer. Centuries after that, astronomers in Baghdad measured it again from scratch and landed just as close. And in 1522, A ship finally proved it the hard way, by sailing all the way around and coming home. That knowledge never vanished. It traveled through Rome, through Baghdad, through medieval universities, all the way to the moment Columbus stepped onto a ship, and all the way past him to the moment a battered fleet finally completed the loop. The flat Earth wasn't the belief people had to overcome. It was a myth invented centuries later to make an old story sound more dramatic than it actually was. You didn't need a satellite to know the shape of your own planet. You just needed to notice a shadow that shouldn't have been there and be curious enough to measure it. That's it. That's the whole method. Somebody looked at a well with no shadow in it and worked out the size of the entire world before anyone had ever seen it from above. And people kept checking that answer generation after generation for over 1,000 years, and it kept coming back the same. So here's the question worth sitting with. What else do we already know for certain today, using tools far more advanced than a stick and a shadow, that people 2,000 years from now will look back on the same way we look back at Eratosthenes? Obvious in hindsight, but only because someone bothered to actually go measure it?